Hello friends, today we will be making chemical bulbs. Yes, you heard me right. It is called acetone bulb, you can say, because it is a reaction where, like, it's not a reaction also, it is a oxidization of acetone, okay, commonly known as nail polish remover. Okay, so it is a so the acetone oxidizes, and you use copper wire. Okay, I made two of them. One is a small one and one is a huge one. Okay, so this copper wire. Okay, this normal copper wire. So heated copper wire, okay, red hot copper wire, acts as a catalyst for the oxidization of acetone. So what happens is acetone vapors, like you pour acetone here, and the vapors come up because it's very volatile. So you keep the jar open for the air to let it surround it, and you can see that the copper wire glows automatically. So I'll just heat up the copper wire. This I have conducted the same experiment before also. So you can see it has changed its color a bit. You can see it has worn down. And this is a smaller version of it. Okay, this is the first time I did it. So like just to make and to see. And this is the second one. I've still not used it yet. So I made the shape of its springs and all. It looks like filament and all. It's little beauty. I'll heat this up. So this glowing enamel upon this will erode and it will burn. You can see the bare copper. After that we can pour acetone and we can see the bulb, like, it will be glowing. Okay, let's proceed to it. Okay, see, so we are here at the kitchen. So we can heat up the copper wire. Okay, and a word of caution, because we are playing with fire and fire is quite dangerous, and plus acetone is a flammable organic solvent, so don't inhale, plus don't let this for fire. Okay, so first we'll pour inside the jar some acetone so the vapors can be allowed to come up. Okay, at that time we can heat the copper wire too. First we'll spread the acetone at the base. A strong smell arises, so keep your face away from this and cover it, or it will just evaporate the full thing. We will do the same for the small one also, and remove the copper wire, because if it's on the copper wire, it will burn the acetone. So you don't want that to happen. If the blue flame, and it will not burn the enamel of it also. Quite nice. Okay, so now we will on the gas and we will start to heat the copper wires. Okay, it's on fire. Be careful while doing this, because we want it red hot, and you have to immediately put it inside the. See, you need red hot. See, red hot. And as soon as you put it, it will start glowing. So don't worry. You see that it will remain glowing, and let the air go and off. So open it. And the other one, as fast as we can. This will burn because of the enamel. Don't worry, that's just an enamel burn. You see there. You need to make it red hot. put it fast. Okay, that's caution because that touches the this and the acetone literally burns up. Okay, so both are set. Let's off the lights. Woo! That literally succeeded in glowing. I close this door. See that? It's literally amazing. And this does glow, but it's little, I don't know. Maybe because of the lack of acetone in that. See? Turn the back on. So that's how you can see it. It keeps on going till the acetone is like, fully oxidized. So it keeps on going. Keep this aside. You can stare. Okay, you can see it. Let's try this once more. Let's put some acetone first. And to make this work. Okay, nice. The vapors come out. Let's heat this again. You can see that it still glows. Like this one, it still glows. You see. See, it's glowing because of the acetone vapors, and it acts as a catalyst, so it glows with it. See, it just got off because the acetone is finished oxidizing to its fullest. This is also ready. This too is glowing. Wow, that's turned to be like real bulbs. You see the filaments like really glowing. And this really gets hot over the jar. It's really get hot. I'll try to focus it. Some low light. So you can see, it literally the color like varies because of the vapors coming out. Amazing, right? It's like almost a chemical bulb you have made. And if you don't believe, the second you remove it, it just degrades and stops. See, it just stops. Try again to put it in May, but it just doesn't. Okay. So that's how we do this experiment. Okay, this was quite interesting. Yeah. I placed the red hot copper inside. You can see it glowing. Wow, beautiful. In real life it looks so beautiful because it looks like a bulb, I'll even try for the next one also. The bigger one. You see this one is much more bigger and brighter as compared to this. See, this looks so beautiful. You can see it in low light. You can see how the colors vary inside the copper, you know. See that? Beautiful, no? This one is trying to keep up pace, but it is not happening, you know. I expected. This heats up a lot because it's happening at a quite huge pace. Lights on, and that's how it looks. Yeah. So you can see it's still glowing. And actually, what's happening is that, no. Okay, I'll just keep this at its two corners. So actually, what is happening is, oh no. Okay, now perfect. So actually, what's happening is that, see, you see these two copper wires. Okay, so heated copper. We heated the copper. Okay, sorry. We heated the copper and then we made it like red hot. Okay, so what happens is that the heat provided by the copper wire and even the copper, okay, acts as a catalyst. So what happens is that vapors are coming up. Okay, it's evaporating, and they meet this heated copper, and it, heats it up more because of the acetone. Okay, so the acetone oxidizes, and the copper wire makes it faster. So that's why. So you can see it as a red glow. Okay, this got ended up glowing because the acetone is like just done. There's nothing left. There's only liquid left. So you can see it still trying that one corner. It's nearest to the base. That's where the acetone is. So that's the nearest where the vapors come. Okay. So like that, you can see like a bulb and no electricity. This is a chemical bulb. Just keep this staring at all day, It looks so beautiful. You can see the color varying and all, You can see it here. That is because there are different regions of, acetone oxidizing. And you see now, okay, you see it glowing. I take it out. It's just done. So it is not providing any heat source or something. It's because of the oxidizing. Now it won't work because it's not red hot copper. And the jar becomes like quite hot, Area above and all becomes quite hot because of the heat. The copper is heated all the time. It's not the color, it's the heat which is taken. It's like that. And thank you for seeing this video. Bye. Low light video of the filament. It just looks so beautiful. More than 1 minute it's glowing. Getting dimmer. finished. No, it's not. It's got really dim. See, in low light you can see properly. It's 2 minutes now. Still not done. Like I can conclude with it, like more copper you use, it is not effective. The lesser copper you use, it heats up more red, So it tends to glow more bright. And even taking a wide mouthed flask or like the jar will help more. Like, I've concluded these. I don't know if it's true or not. I just concluded these. You see, because of the small jar only, such a small part is happening. And that copper wire was loosely wound, the bigger jar one. You can see. Now it's going to be 3 minutes.
This one is so bright.
So time for next. This is in low light camera. See, it's wide mouth and it's a huge jar. It's quite bright. Yeah, it's 1 minute. But still, it just got too dim. Okay, maybe the lid takes. Maybe it evaporates faster with a wide mouth. I just get confused. How does this happen? Oh, that's done.